Welcome to another video. In this video, we're going to be focusing on stationary points. Now, at the end of this video, you should be able to 1. Identify stationary points, 2. Find the stationary points of a curve given the equation of the curve, and 3. Determine the nature of the stationary points. So, let us begin. Now, if you observe this curve, you will realize that as the curve goes up, when it reaches this point, it starts going down. As it goes down, when it reaches this point, it goes up. So at these 2 points, our graph turns. Now, these are called turning points or stationary points. So our stationary points are 2, 5, and 6, -5. Why? Because it's at those points that our graph turns. Now, how do we determine our stationary points? Now, if we were to draw a tangent at the stationary points, or tangents at the stationary points, you'll realize that these tangents are horizontal. And this tells us that the gradient at our stationary points is 0. Now, at some point, you should have learned that the gradient of the tangent is just the derivative, or is found using the derivative of the curve. So that means that at the stationary point, dy by dx is equal to 0. So to evaluate, to find the stationary point, we use the fact that dy by dx is equal to 0. Now, another thing is, if you look at the shape of the stationary points, now here we go up and then it goes down. So this is what we call a maximum stationary point. This, we're going down, we turn, and we start going up. This is what we call a minimum stationary point. We'll talk more about that shortly. Alright, so now we look at how do we use the fact that at the stationary point, dy by dx, the derivative, is equal to 0 to find the coordinates for the stationary point. So we start off. So recall that at the stationary point, dy by dx is equal to 0. So it means that we need to differentiate our function. So for this function, dy by dx will be equal to, so differentiating here, we have 3x squared. So we bring down the power sub and then subtract 1 to get a new power. Minus differentiating 3x gives us 3. So this tells us that 3x squared minus 3 is equal to 0. Now it's just a matter of solving this equation. So we can factor out 3. So we have 3x squared minus 1 is equal to 0. So this is the same, x squared minus 1 is equal to 0. X squared is equal to 1, which means that x is equal to plus or minus 1. So we have two x values. We have when x is equal to 1, and we have x is equal to -1. Now a point has two coordinates. It has the x coordinate and it has the y coordinate. So we need to find the corresponding y coordinates. So the stationary points are, now we know that one of them will have positive 1 as the x coordinate. So to find the corresponding y coordinate, we substitute x as 1 in the original equation. Now, a common mistake that I see is students often substitute 1 in dy by dx in this here. Substituting 1 in this will give you the gradient of the tangent at x is equal to 1, and we will always get 0 because that's the stationary point. Alright, so to find the y coordinate, you need to substitute it in the original equation. So please remember that. So we have 1 cube, that's positive 1, minus 3. So 1 minus 3, negative 2, negative 2 plus 5, that's positive 3. And the next one will be when x is negative 1. So when x is negative 1, we have negative 1 cube, which is negative 1. Then so we have negative 1. Then negative 3 times negative 1, that will give us positive 3 plus 5. So negative 1 plus 3, that's 2. 2 plus 5, that's 7. So it means that our stationary points are 1, 3 and negative 1, 7. Alright, now we'll look at how do we determine if our stationary point is a maximum turning point or a minimum turning point. Alright, and to do that, we're going to do that using our second derivative. Now, if the second derivative is greater than 0, so if the second derivative gives you a positive number, then we have a minimum stationary point or a minimum turning point. If the second derivative is less than 0, so it's a negative number, then we have a maximum turning point. So a stationary point is a maximum. Alright, so what that is saying is if the second derivative is greater than 0, now we have a shape like this, like a valley at the turning point. And if it is a maximum stationary point, so if the second derivative is less than 0, then we have like a mountain, we have a peak. Alright, so it means to determine the nature of the stationary point, we need to find the second derivative. So our first derivative from the previous question is 3x squared minus 3. So our second derivative, d squared y over dx squared, is simply 6x. Now we determine if this is greater than 0 or less than 0 at our stationary points. Alright, so at 1, 3, d squared y by dx squared is equal to 6 times the x coordinate, which is 1. So 6 times 1, which is a positive number. And since this is a positive number, we know that it's greater than 0, so it means we have a minimum stationary point. So therefore, minimum. At negative 1, 7, we do the same thing. So the second derivative, d squared y over dx squared, is equal to 6 times the x coordinate. In this case, it is negative 1. So we have a negative value. And therefore, this is a maximum turning point. And that's how we evaluate the nature of our stationary points. It is also possible for you to be asked to classify the stationary points. That is the same thing as determining the nature of the stationary points. Alright, now thank you for watching this video. In the future, we'll be looking at minimum and maximum problems as well as curve sketching.